Okay, so for the first one, those are gears. It's gear ratio. What do I do with each gear? First, what information do I get from each gear? There's 10 teeth here and 6 here. Which one goes on top? 6. So that'll reduce to 3 to 5. Remember, it's driven over driving. If you separate them, one will keep turning. That one goes on bottom. The 10 will keep turning. No, 10 is driving. If I separate them, the driven gear stops because it is being driven by the other gear. It is. That makes it the driving gear. Yep. It is. Remember, it's not the power source. It's the intersection of the gears themselves. One gear is driving the other. The 10 is driving the 6. The 6 is being driven by the 10. So then for number 2, which one goes on top? 16. 16 over 6, or an 8 to 3 pulley ratio. Any questions on those two? Okay, 3 and 4 are ones that we didn't really talk about, but wanted to see what you can pull together with ratios. A good to defective ratio for 400 parts produced with 2 defectives. Careful. Why is it 398? Yeah, 300. You got it. 398 is your total parts. So only, or 400 is your total parts. 398 is how many are good out of the 400. Now, number 4 is actually a very important ratio. If you ever go to borrow money, this is one of the things they look at. You hear a lot about credit score as far as borrowing and stuff like that. Credit score does not necessarily determine whether you get the loan. If you have a horrible credit score, I mean like below 620, then you might not get a loan, because to get a score that low means you've had some credit issues in the past. Generally, if you've got a credit score above that minimum level, all the credit score really determines is what interest rate you're going to pay. Like if you're, depending on the bank, it's 710 or 725 is kind of the cutoff between average and good. And if you're above that 725, let's say, you get the really good rates. Like you get 2% loan on your car, the 1.9% loan for your car, or whatever. Below that, you get higher rates. If you get way up there, like in the 800s, above 775 usually, then you get some premium rates. So the credit score just determines how good of a deal you're going to get. What determines whether you actually get the loan or not is your ability to pay. And a debt to income ratio measures your ability to pay. So here we have debt payments, a car loan of $300 a month, credit cards of $200 a month, and a house of $500 a month. That's $1,000 per month. And you take your income, you're right, 20 times 160 is 3,200. So it's a debt to income of 1,000 to 3,200, which of course is going to reduce to a 5 to 16. Debt to income ratio. What banks usually look at is something less than a 1 to 3. A 5 to 16 is actually less than a 1 to 3. So that's not a bad debt to income ratio. Doesn't mean they're going to give you the loan, by the way, because it depends on how much you're trying to borrow. A lot of times I'll put out the scenario where you have a car payment of $300 a month and you have $200 a month in credit cards, and asking if you're applying for this home loan and the predicted payment on the home loan is $500 a month, will you get it? Well, yeah, because even with the 500 added in there, you're under 1 to 3. But 1 to 3 would be, 5, another, what would it take? $600 or $670. You would be above a 1 to 3 here. So that, not even $67. So you can't borrow anything that would be more than a $67 a month payment and stay under that ratio. You know, the big mortgage crisis in 2008, 2007, 2008. One of the big reasons for that is government regulations actually pushed banks to adjust that ratio. Instead of 1 to 3, they wanted to push it to a 2 to 5. And they did it in certain conditions, like impoverished areas, cities where there's a higher rate of poverty and stuff like that. They were pushing that. Single income households and things like that. Well, you had two problems there. You had risk factors. You had a population that you were giving loans to that typically had a harder time repaying. And then you were pushing that debt to income ratio so that their payments were higher, which meant they had less of a cushion. If they had any sort of cutback in hours at work or whatever, they didn't have that cushion in their paycheck to still continue making their payments. So they were giving loans to a number of people that they knew were going to struggle to repay them. Yeah. Mm-hmm. If they met certain criteria, they waived those debt to income ratios. Yeah. And there were also a number of people, they're a little bit tighter. I know they'll still do it, but a little bit tighter. They were giving loans to couples that were not married. And they were still allowing them to count their income as joint income. And they still do it some, but they're a lot more restrictive on how they do it. So if a couple split up and one of the incomes was gone and the one was left still trying to pay the payments, it was tough. Sure, which one? Okay, let me get that back out. Page 227. Which one? 9 through 12. Okay, playing with the variables. So for number 9, this is page 227 in the packet. I'm going to write it as a fraction because it's simpler to work with for me that way. 3a squared b over 9ab. Rob, this might look more familiar to you from the summer and from last spring for you. These are just fractions with variables in them, ratios with variables in them. 3a squared b, I'm going to break up that a squared into a times a. 9ab, I can cancel out an a and I can cancel out a b. Both 3 and 9 divide by 3. So 3 divided by 3 is 1. I'm left with just a on top. 1a or just a. On bottom, it's 9 divided by 3 is 3. So that's a over 3. I won't ever do that to you on a quiz. I throw them in there just because working with the variables is something it's a handy tool, but I won't do that to you on a quiz. This class is not about variable manipulation. Now you get to like 11 and 12. Let's do number 11. A 2/3 to 1/2. Well, if you're stuck on the whole ratio and trying to reduce, this can be a tough problem. But if you just look at it and realize the way it looks has a couple of different meanings. One of those meanings is 2/3 divided by 1/2. Of course, 2/3 divided by 1/2 is 2/3 times 2 over 1, which is a 4 to 3 ratio. 4/3 or a 4 to 3 ratio. No, you divide, you invert and multiply. Remember, cross multiply and divide as if there's equals between them. There's no equals between them. Any other questions off the homework? Yep. Exactly. Just like if you have like 2/8, well, divided by 2, the 2 cancels out. Well, that's still a 1. Yep. So exactly. The x cancels out, y cancels out. You've got 1 over x. Yep. Any others? Okay. So today we're going to take that next step. Now that we have these ratios and we know what many of them mean, we can figure out what they mean. What do we use them for? Well, we could have, and what we're going to be working at is what we're going to call direct proportion. Back here. So we call it direct relationship. And this is the most common thing that proportions are used for. Directly proportional or direct variation, direct relationship. All that means is when one value gets larger, the other value also gets larger. Or the other way around. If one value gets smaller, the other value also gets smaller. Not necessarily by the same amount, but by a common factor, a related factor. So for example, let's say that you need, because of the RPMs of a motor, you require a 3 to 5 gear ratio. You have a motor with a 30-tooth gear on it. How many teeth do you need in the other gear? So we've got that 3 to 5 ratio. Now I am going to put equals there. This is a proportion. I need to create a ratio that is equal to that. But I need to account for the fact that there's 30 teeth on the motor. Which of those numbers, the 3 or the 5, represents the teeth that's connected to the motor? The 5, that's the driving gear. What's connected to the motor is the driving gear. So the 30 teeth on the motor relates to the 5. So that goes on bottom because that represents the teeth on the motor and the 5 represents the teeth that would be on the motor. And now this is where, because it is one fraction or one ratio equals another ratio, you could do 5 times 6 is 30 and 3 times 6. Or you could just do 3 times 30 is 90, divided by 5 is 18. Either way. Cross multiply and divide. So either way, it's 18 teeth in that other gear to maintain that ratio. Now, what you were doing there where you multiplied both of them, that worked in that one because it worked out nice and even. But it doesn't always work that way. Let's say I have a proportion that looks like that. I can't look at that and say, well, what times x makes 9 or what times 4 makes x? It doesn't work out. But I can cross multiply. Now, we've been cross multiplying and dividing, but there's another process where you just cross multiply, and the two diagonal products have to be equal. What I mean is you go this way. This is one diagonal. 4 times 9 is 36. Here's the other diagonal. X times x is x squared. Those have to be equal. X squared has to equal 36. Now I would solve that for x by x has been squared. The opposite would be square root. So the square root cancels out the squared, so that's just x. 6 or negative 6. Because negative 6 squared. Positive, exactly. Negative 6 squared would also be 36. We will run into proportions that are set up that way, or that we have to do that with. If you had just a positive 6. Something like this. Solving for x. Now, x isn't by itself, but I can do that cross multiply thing. Here's one diagonal. 10 times 50 is 500. Here's my other diagonal. That's going to be 20 times x minus 7. I know those two have to be equal. 20 times x minus 7 has to equal 500. So now, to solve it, I have to multiply the 20. 20 times x, 20x, and 20 times negative 7, negative 140 equals 500. And then add 140. 20x equals 640. Divide by 20. X equals 32. What do you think? Oh, come on. Oh, it's never too late to start.
I'll try to figure it out when I'm done. I'll come to you on your deathbed. I'm seeing the light. Give my last gasp. It makes sense now.
So, something like this. This is getting a little ugly, but it's still not out of our realm. Doesn't matter which direction we go first. Let's go this diagonal. Now, it's always easiest for me if I take the whole number times the expression. So this is going to be 39 times 3x minus 5. Go in this direction, it's going to be 30 times 2x plus 3. There isn't room, so I'm going to move down here. Doesn't matter which one I put first here. 30 times 2x plus 3 has to equal 39 times 3x minus 5. And then, perfect. 30 times 2x is 60x, and 30 times 3 is 90. On the other side, 39 times 3x is 117x. 39 times negative 5 is a negative 195. And then we've got an x on each side. There's nothing more we can simplify on each side. So our next step is to look to make sure if x is only on one side, but it isn't. There's an x on each side, so we have to get rid of 1. Subtract 60x. So 90 equals 57x minus 195. 57, yes. And then add 195. So 285 equals 57x. Divide by 57. We get 5 equals x. What do you think? Good stuff? You can get into it, yeah. Now, some things with these. Look at that as just a generic ratio. A to B equals C to D. A over B is equal to C over D. Some things that we can do with these that will not change the result. First of all, if we flip it over, does that look reasonable? Does that look like it'll work? Well, let's look at those cross products. Over here we had A times D, right? Over here we had B times C, which is BC. So AD has to equal BC. Over here, BC and AD still equals BC. So that's okay. We can flip both upside down. As long as we flip both ratios, we can flip them upside down. Can I trade spots with those two? D over B equals C over A. Well, here I've got D times A, which is AD. B times C, which is BC. It's still AD equals BC. Because those two are just going to be multiplied in the cross multiplication, I can switch them. Which then means we can switch which other two? The B and C are going to get multiplied, right? So I put the A back where it was. If I put C down here and B up here, that doesn't change anything. Because C times B is still BC, A times D is still AD. So there are a lot of things we can move around on these, and we still have a true ratio. And let me show you why. So here's our pulleys. This pulley ratio is 4 to 10, which reduces to a 2 to 5 ratio. If I replace this motor with a motor that has a larger pulley on it, this is now a 15-inch pulley. I have to change this pulley in order to keep that same pulley ratio. Keeping the pulley ratio keeps the RPM constant. Well, I have this ratio here, 2 to 5. The 2 is the driven, and 5 is the driving. These two numbers are both the before. We want to look at the after we switch them, right? So in the after, the 15 goes on bottom, right? In fact, it might even be more clear if I leave this. Instead of going to the 2 to 5, we're going to leave it as the 4 to 10. The 15 is the one attached to the motor. The 10 was the pulley attached to the motor. Cross multiply and divide here. 4 times 15, I'm going to get 6. But I could have set it up a different way. Instead of the before on the left and the after on the right, I could have done before on top and after on bottom. What that would do then is we got driven and driving. Doesn't matter which one I put on the left or the right. The driven, before, that's the 4-inch. After, that's what I'm looking for. Driving, before, that's the 10-inch. After is the 15-inch. You'll notice that it's still, just like up here, it was 4 times 5 divided 4 times 15 divided by 10. Here it's still 4 times 15 divided by 10. So that's one of the powers of these proportions is there's a lot of different ways to set them up and they're still going to work. What matters is that the relationships are held constant. There has to be a relationship going horizontally. Both of these are from the driven gear or driven pulleys. Both of these are the driving pulleys. That's the relationship going horizontally there. These two are from the before. These two are from the after. That's the relationship going vertically there. Over here, we just switched the orientation. These two are from the before. These two are from the after. Instead of the making that vertical, we did that relationship horizontal. These two are from the driven. These two are from the driving. Both relationships are still there. We just put them in a different orientation. And that's the thing with a proportion. Anytime you set up a proportion, the number that goes here better have a relationship with that number and a relationship with that number. It's a different relationship, but it better be there. In this case, these are both the before numbers, and this is driven to driving. Over here, the relationship is still driven to driving, but those are both the after numbers. So if you're looking at these and you're not sure how the ratio should be set up, whether it should be 4/10 or 10/4, if you're using it to find another gear, it doesn't matter, another pulley or whatever, it doesn't matter which one goes on top. What matters is that you set them both up the same way. They line up. Probably the best illustration of that is in similar figures. Similar figures are when you take one figure and you just enlarge it to get another one. For example, let's say you got a triangle like this. This is 6 inches, 10 inches, and 12 inches. If I enlarge that triangle, so that this here is now 15 inches. I'm going to tell you that this angle and this angle are the same. These two angles are the same. And of course, by default, the third one has to be the same. I have those other two sides, X and Y. I can find those sides because of the relationships. Typically, what I do is I match up corresponding sides. I know the 15 inches in this triangle. What side of the other triangle corresponds to that? The 6 inches. Good. How about the X? What side of the other triangle corresponds to the X? The 10. So if I want to find the X, I'm going to use the relationship where I have both lengths. That's the 15 and the 6. Does it matter whether I put 15/6 or 6/15? No. But when I go to put in the X now, X is from the same triangle as the 15. So it's got to go with the 15. Depending on which one I put it in, it's got to go in the same position as the 15. What goes above it or below it or whatever? Well, from the other figure, what side corresponds with X? The 10. Notice that 10 fits in there because it has a relationship in both ways. The 10 is the side that corresponds to X, but it's from the same triangle as the 6. It has that relationship with the 6 and with the X. The 15 and the X are from the same triangle. 15 corresponds with the 6. It has that relationship in both directions. Now I can find X. 15 times 10 is 150. Divided by 6 is 25. So X is 25 inches. To find Y, I'm going to do the same thing. Again, I start out with the two sides that I know from both figures. That's the 15 and the 6. I'm just going to write it out one way this time, 15/6. Where does the Y have to go? Top, because it's from the same figure as the 15. So it goes with the 15. And its corresponding side from the other figure is the 12. So 15 times 12 is 180 divided by 6. Y is 30. Now, it's not always that simple. These are both in the same orientation, just enlarged. They might not be in the same orientation. So we might have now I probably should tell you this angle and this angle go together, and that angle and this angle go together. Which side of the other figure corresponds with the 60 feet? 60 is between the single mark and the unmarked. Single mark and unmarked, that would be the Y. How about the 30? The 20. It's between the double arc and the unmarked. The double and the unmarked is the 20. So that should leave the X corresponding with 50. Which one do I have the number from both triangles? 30 and 20. Again, I can do 20 over 30 or 30 over 20. Does not matter. I'm trying to find X. Does X go on top or bottom? X is from the same figure as the 30, so it does go on top. What goes below the X? The 50 is the corresponding side from the other triangle. So now we cross multiply. 30 times 50, 1,500, divided by 20 is 75. So X is 75 feet. Same process will get us Y. 30 over 20, does Y go on top or bottom? It is from the same triangle as the 20, so yes, it goes on bottom. What goes above it? Corresponding side from the other triangle is 60. Cross multiply. I don't know why my Y will not stay. Stay. Twenty times 60 is 1,200. Divided by 30 is 40. So Y is 40 feet. Any questions? Okay, so good. For Monday, we don't have class tomorrow, do we? In the second packet from yesterday, page 228 through 229, I want you to do 17 through 45.